Good morning, y'all. My name is Randy Bartley. I'm moderating this track. Let's see, Melissa Dakas is our next speaker, going over methane reductions initiatives and how to plan for that appropriately. Melissa has a background in engineering and business professional with extensive specialized complex environmental regulations. She's continually recognized for excellence in problem solving, forming strong interpersonal relationships, her broad technical expertise, and effective project management.
Okay, sure. Okay. Good morning, everyone. Thank you for joining. So my presentation today, I think, is going to kind of take a step back from the real nitty-gritty on the technical pieces that a lot of our presentations across this conference are providing, but kind of give the setup as to why a lot of this is really important moving forward with the oil and gas industry. So what I want to talk about is really methane reduction goals, greenhouse gas reduction goals. That seems to be a hot topic for everyone, and how we can go about doing that successfully and setting these targets and then delivering on them. And the 10-second spiel on Montrose Environmental is we are a comprehensive environmental consulting and provider firm, both with field services as well as professional services. We have over 2,500 employees, both domestically and with international locations, and 70 offices headquartered in Little Rock, Arkansas. Excuse me, these are not advancing. So this, we're gonna be a little funky. Try this. As I mentioned, stack testing, LDAR, OGI, laboratory services, remediation, that makes up kind of the continuum of Montrose Environmental and all those pieces. I represent advisory services. It's a newer business line for Montrose, in which we're kind of trying to take all of these pieces that have been traditionally serving the regulatory compliance space for clients, but now as we're moving into kind of the voluntary initiatives that are facing our clients, kind of the biggest environmental challenges, one being climate change, sustainability, water scarcity, et cetera. How do we take our expertise internally and be able to serve our clients in these additional challenges spaces? So it's going to be kind of more based on strategy and implementation that's outside of our typical regulatory drivers in this case. There we go. So what do I want to go through is really just, again, what are the biggest drivers that are driving us to talk about setting methane and greenhouse gas targets? What are the components of a greenhouse gas inventory? We're traditionally in this space building inventories based on our subpart W reporting and other things, but there's a lot more that goes into this, especially when we're talking about reductions and targets. How do we set a successful reduction target? What should be the components of that? Then I'll talk high level about some GHG reduction methodologies and strategies, and then how do you get started? So as the oil and gas industry is facing this unique challenge of climate change, one of the biggest pictures, and I think the presentation beforehand kind of teed up into this, is do we really understand what our emissions baseline is in the oil and gas space, especially when things are driven primarily on emission factors and various other estimating approaches with that. And then how do you commit to a reduction target and can move forward with that? Especially if you have in the case of leaks, if you're using in a population count or emission factor, if you don't change anything about what you have in the operations, those emissions will be exactly the same today as they are tomorrow, even if you do make reductions in the field, if that's the way you're quantifying emissions. So it's understanding how are we quantifying these and then moving forward. So we have to start with saying is why does it matter? Why is methane such a big deal, and why is oil and gas being targeted in this case? It goes without saying that if we're going to hit the 1.5 Celsius pathway, it's not going to happen without, in various studies, a 37% decline in global methane emissions. Provided that methane is contributed over 30% of the global warming to date, and it's possible to reduce over 70% of the current oil and gas methane emissions with technologies we have available today. Layer on that, a lot of that can be done without an actual outlay of costs, meaning the reductions that you recognize with the capital outlay will balance themselves out by increased sales of that product. So oil and gas is really teed up in the sense to be able to make a difference in this space on reductions specifically in that. But the big piece is that methane abatement requires better measurement. So there will be endless presentations throughout this week here at this conference talking about the measurement of methane, identifying that. I think we here domestically in the U.S. are much more advanced, and in other places in this graph here over on the other side is indicating that what we're reporting on our emissions across the globe in this space versus what is actually being emitted, there is a huge differential there. But being able to better detect and identify so that we can go ahead and mitigate those emissions is going to be a huge component of this, of achieving our reduction targets, both on an individual company basis, but then also kind of on the global across the industry. There's also regulatory drivers right now that are coming. So even though I said that this is kind of a voluntary space, let's face it, we've got the proposed SEC disclosure that has just been released that is going to drive companies to report on their greenhouse gas emissions across their operations. We've got proposed EPA NSPS Quad O, the revisions to A in Quad O A and Quad O, but then the addition of Quad O B and C that is also going to drive us to, again, adding on some technologies for reductions. We've got state-based regulations that are coming on that are targeting these areas. So all of this is really, again, focused on the methane, which is driving the industry to look at, to better quantify and reduce their emissions in this space. What are the non-regulatory drivers here domestically? I think it goes without saying that oil and gas gets a pretty bad rap in the public in a lot of cases. I mean, public perception. I can't tell you how many articles I read on a weekly basis that are targeting one thing or the other in this case. It's all driving of the assumption, and in some cases true, but in a lot of cases not, of companies being very high methane emitters. The improved profitability. I mean, again, if we look at the fact if we can reduce how much we're emitting to the atmosphere unintentionally and actually get that back into our sales line, there's been studies out there saying there's the potential of $34 billion a year in lost product that can be realized in this space. There's a lot of pressure from investors. So we're seeing a lot of the external stakeholders. People want to understand what you're doing, and that feeds right into ESG reporting. Again, with companies having to now quantify both their environmental performance as well as the social and governance performance against this. And we'll talk a little bit about what some of those reporting frameworks look like. All of this is driving into understanding of better quantification and reduction in methane emissions. It goes without saying that if we didn't have enough going on here sort of locally, on the international scale, is other things that we have to keep in mind. Specifically, if you look at here kind of with the politics of what's going on in the world, for sure, we are becoming one of the largest exports of natural gas and liquefied natural gas in the world. Our customers internationally are making commitments and driving to better reduction performance. Therefore, they are going to expect that on their suppliers. So differentiating your product and in the industry of understanding what the methane intensity is specifically to what you're producing is going to become very, very important kind of on the international market scale. European Green Deal, this is where those member states actually committed to the first climate neutral continent by 2050. So these are pretty aggressive goals, and they're going to require others to kind of work towards them in order to achieve these. a lot of pledges going on, the Global Methane Pledge. All of these are, again, driving to specific reductions, measurable reductions by 2030, 2040, 2050. These are the target dates that we're looking at. So these are kind of setting the stage for what we, as companies, when we're thinking about how are we going to set our own particular goals, are we aligned with kind of what the world is looking at and what some of these pledges and these other things are kind of pulling together in this case. I think it goes without saying too, we're hearing a lot about this carbon neutral liquefied natural gas deals. So this cargo tags, which kind of starts all the way from the well to delivery to the customer, trying to understand what the actual carbon outlay or the methane intensity is for that particular product, and that's going to start all the way from when it's coming out of the ground. So we're seeing folks the need to reduce the overall emissions going all the way from the beginning of the supply chain all the way. Bring this up again. So oil and gas obviously covers a lot of different things, but this is one of the bigger drivers we're seeing with again the value chain in this area, and how if a company wants to purchase a carbon neutral shipment, where does that start, and how are all the different contributions going through into that? So just kind of starting right from the upstream and then liquefaction and going through. So these are just all of these pieces kind of set the stage to what is driving companies to kind of think about where are we currently and how do we set a reduction goal and target moving. So what are the components of a greenhouse gas inventory? Scope 1, which we'll talk about, are direct emissions. It's what we typically are dealing with on a day-to-day basis. That's what we're reporting under Subpart W and other greenhouse mandatory reporting rule. But there's a lot of other components that are now also becoming part of the narrative. Our Scope 2 emissions, which are indirect emissions, are the indirect emissions that are generated as a result of our operations, as well as the Scope 3 emissions, which we'll talk about. It goes without saying, just to kind of set the stage to talk about each of these. So Scope 1 is the direct emissions. It's those items that are emitted from the nature of your operations. It's the fugitives. It's the incomplete methane combustion from either stationary combustion units or flaring, vented emissions. All of that would constitute what is included within our Scope 1. A lot of these are currently derived either by emission factors or through some measurement and monitoring, as well as engineering estimations, software, etc. Scope 2 is going to cover our indirect emissions. So those are going to be the emissions that are generated from the purchase of electricity or steam or other utilities in this case. These are quantified with emission factors, but it's going to be how much electricity are you using across your operations that are going to feed into, including within your overall inventory. These are typically fairly large sources of greenhouse gas emissions depending upon your operation, especially if you're looking at one way of reducing is electrifying all of your compression. Then you're going to reduce in your Scope 1 by the reduction of fossil fuel emissions, but you're going to increase your Scope 2 because now you're purchasing a ton more power in order to get the same operational conditions. However, there's ways to address the Scope 2 emissions, I guess, in looking at reductions on purchasing renewable power, etc. But it's important, and this is why when you really want to understand what a full baseline is that you have to evaluate each of these pieces within the Scope 3 is the one that gets, I think, it's talked about the least in the sense because it's always a little vague and unknown. But these are all of all the other indirect emissions that are associated with your operations. So this can occur both upstream and downstream depending upon where you are in the supply chain. The actual purchasing of the raw materials, the transportation of your product to its end location. Technically, Scope 3 also would account for the combustion, for example, of oil and gas in its end users, various other pieces. The accuracy of this can be kind of difficult because it's hard to collect some of this data, and in some of the reporting structures, they do want to have your scope 3 emissions, specifically in the SEC proposed rule. They're looking for scope 3 emissions as part of operations, but these are calculated a lot using your activity data, so understanding how much you're purchasing, how much you're selling, various other pieces. But this is also another piece that's important to consider in the overall inventory and boundaries of your gas emissions. I use this as an example. I've pulled this from an API, a document. I think it just kind of provides a good pictorial on. In this case, we're assuming kind of a refinery, but we could say gas processing or anything else in between. But with your direct emissions kind of occurring within that dotted box, all of those scope 3, both in both directions, are represented by the arrows that kind of go through the actual operations in this case. So as I mentioned, purchase of raw materials. If you're looking at on the refining side, for example, the exploration and production is going to be your indirect emissions. That operation waste from those operations, the transportation of the materials, product disposal, all of that feeds into what would be included in that broader scope 3 definition for this. So now we've set high level what's included in the baseline. Go ahead and determine a reduction goal. There's 3 main components that's going to feed into what that particular target is going to be for a company, and this can be applied again at a small scale of a couple of smaller operations, or obviously a large enterprise scale for. But the 3 main components that are very important is one is setting up your baseline and understanding what that is, making sure it's as accurate as possible. Next is what kind of target are you going to set and work towards. And then the final piece is sort of what is that level of commitment and how aggressive do you want to be? Are you planning to be net zero by 2040? Is this maybe a 15 or 20% by 2030, et cetera? But understanding what is your company's level of commitment, and that can be driven by a number of those initiating factors, those market drivers that we mentioned at the top of the presentation. Is it your external stakeholders that say you have to reduce? Is it, are you selling to companies that have very strong ESG programs that want to ensure that they're only working with operators that have a particular methane? There's lots of pieces that go into that. So to me, this is kind of the biggest and kind of important piece of setting up that baseline is first you have to define the organizational and operational boundaries that you are addressing. If you are an operator in which you own or have assets that you do not operate or have joint ventures or various other things, being able to draw those boxes accordingly over, as I will say, your sphere of influence on what you actually can control is important, and being able to define that very clearly on what you want to move forward to. That could be operationally. You might want to group things differently by geographical location, by basin, by areas that make sense, especially when moving forward in doing your reductions. Under that, you need to identify all of your sources. We have current reporting rules and templates that tell us we have to quantify from the subpart W defined source categories, but no, in a true full inventory and baseline, we have to include everything else that may not already be included in there. That could be something as simple as even emergency equipment, portable or mobile sources that are part of your direct emissions for your operations, various other venting, maintenance, startup, and shutdown emissions. All of that is then going to be included, and make sure you identify specifically what is within that operational boundary that you've defined. Next, how are you going to quantify? What's the calculation approach? In some cases, it might be direct measurement. I don't want to completely throw away emission factors, but in some cases they're relevant in this case. But understanding how is the best way to quantify and know what kind of activity data you would need in order to set that calculation up for each of the sources. Collecting the data, so going out and doing a good inventory of what data that you have, and maybe you have to add on some additional monitoring in order to get the data you need. Do you have fuel meters on your compressors, for example? Or are you just using hours of operation? Trying to be as accurate as possible to get the information that you need to go through and to perform those calculations. Obviously applying the calculation tools and then rolling up all of this data. But kind of walking through each of those steps in order to set up this baseline, but making sure that it's comprehensive across all of the operations that you have. These are the buzzwords in which you want to ensure that your baseline and inventory fall into each of these categories to the best of the ability. So first is transparency. It's really hard to, in this day and age, with the perceptions that we have, being very transparent in the data of where it's coming from, how it was quantified, calculated, is going to be really change that perception. I think we're finding in the presentation prior to this teed it up very well, is that using the emission factors versus using direct measurement or monitoring does a huge delta in the actual reported emissions. Being able to understand and explain that, where people are seeing a huge change. Well, was there a change in operation? No, there was just a change in methodology. So therefore, being transparent as to what is where you're seeing those changes, how the data is being collected. Consistency, I think year over year is being as consistent as possible and making sure that the information is collected and reported. Completeness, are all the sources under your operational control being included? Do you include each and every source category? Are those one-off types of emissions that don't maybe occur on a regular basis, such as maintenance, startup, shutdown, blowdowns, venting? Is all of that included in your overall? Accuracy, is this data verified? Is it checked? This is a huge, we see a lot more companies moving forward having third-party verification of their greenhouse gas emissions for this point, just to kind of verify too that other people are checking and verifying that yes, you're following all of the frameworks and protocols that are out there. And then finally, kind of the relevance. Are you relevant in what you are quantifying, again, with your operations, and assuming everything's in there? There's a lot of, as we're moving forward, there's a lot of sustainability reporting frameworks out there that will help to drive what best reporting and this quantification may look like. I've touched on a couple here: the CDP, GRI, SASB, GHG protocol. If you're trying to figure out how to go about doing everything that I just kind of talked about, or what might be the methodologies to use or the approaches, these particular reporting frameworks are going to provide a lot of that guidance for you. So in a sense, where this is kind of unique is there's no one-stop shop as to how the industry can move forward in their reporting of these emissions. There's a lot of different protocols that you can follow. And then specifically to the oil and gas, a lot of other reporting guidelines too that can also help to tee up how you're going to set these baselines, and then obviously the reporting moving forward. The Oil and Gas Methane Partnership, which is based out of the UN, it's really a reporting framework that's driving operators in order to establish source and asset-based emission factors from direct measurement. So it's moving away entirely from using any sort of emission factor, but using direct measurement to quantify and report on emissions. The Natural Gas Sustainability Initiative, I'm going to talk about their methane intensity. Again, that's talking about how to calculate your methane intensity protocol. And then other reporting guidelines, as I said, like the Task Force for Climate-Related Financial Disclosures and the Sector Standards for Oil and Gas, the GRI. So those are specific to the oil and gas space, whereas the slide before was a little bit, those were open to all industries, should we say. But these are going to kind of help in that reporting standpoint. I want to throw this in there because I do think it's really important when we're talking about this space and we're talking about ESG reporting, and a lot of the public facing is that right now, this is the main tool that we have and where everything has been set up for reporting on. But there are a lot of limitations to subpart W, and percentage of the emission factors are driven by population counts, emission factors, engineering estimations that we are seeing clearly are not accurate to what is currently being released in the field. And so if this is the basis you use to not only report your emissions and set your baselines up, but then work towards your targets, it's going to be a real hindrance and limitations to one, either show improvement, or two, it's not accurate as we're finding to what the actual emissions baselines are for operators. In most cases, it's going to result in an overestimation of your emissions. In some cases, depending upon the division of your assets, it could be slightly underrepresented, especially if you have a lot of these extra emissions that are not being quantified in terms of it. It also limits the use of actual measurement or activity data, and I think that's the big one. So if this is the methodology you're continuously using, if it's an emission factor times a number of components, you're never going to show improvement. So if you set a reduction goal and say we're going to reduce, if this is the way that you're quantifying and reporting year over year, there is no actual reduction that will happen using this methodology. I know this is busy, but I put this slide up there just to show this is just a list of all the source types under W. All of the columns all the way over to the left are what is represented by engineering estimates, population counts, or emission factors. So it's just meant to show all the check marks on how many different source types under the rule are driven more from I'll say generic data versus direct measurement in this. So calculating emissions year over year is something that we do. But if you're going to set up an actual emission target, we have to start with a baseline. So how do you determine what your baseline and target years are going to be? The most important thing is, I think, choosing a year that's recent with verifiable data. If you're going to, again, start to make improvements on things, having a good starting point on where you have, choosing a year 10 years ago where you didn't have great data, you can't really verify it, you're not really sure, it's not going to show an actual real reduction in what you're doing from an operational standpoint. So I think best case scenario is really what years do you have the best data, where you have the quantification methodologies that you plan to kind of continue. As we mentioned with that baseline, you want to be consistent year over year to the best of your ability. The target year kind of defines that length of that commitment. So usually there is we'll call it a medium target to a long-term target. Having multiple targets helps to provide those milestones. It kind of drives action. So if you have something that's more attainable, that was a couple of years out with obviously the longer, more aggressive goal, and you can show improvement on that, it adds kind of validity to the overall target setting, and you can actually show progress towards that. So I think right now it's important that we say the 5 to 15 years and the 15 years plus for your overall target setting. So how do you set a target? And there's a lot of different talks out there in the sense of, are companies setting an absolute target, or are they setting an intensity target? Absolute is exactly what you think it is. It's a set number saying we're not going to go over X. Specifically to this industry, that's a very, very, very difficult, given how things change, acquisitions, divestitures. If you're trying to just set a flat out number or a target, and then you keep adding new wells, drilling new wells, et cetera, that's going to be, it's not the best suited for this position. Intensity target, which is going to be a reduction in emissions over an activity factor, whether that be the amount of methane that you produce. It's normalized to a business metric, and that allows for flexibility, allows for growth, specifically within the industry, that it's going to show that overall, yes, you may be doing a lot more production, for example, or processing more gas, but at the end of the day, our overall performance per the amount that we are handling is getting better. There's presentations across here that talk a lot about methane intensity and how we derive that. So I would like to just kind of tee it up and give a little bit of an overview. But the methane intensity is strictly how much methane are you releasing per the amount of gas that you are either producing, moving, processing, et cetera. There are different ways to calculate that depending upon what segment that you currently operate in. The NGSI calculation methodology, I think, is probably one of the most used and is a good comparison. And that's the thing, being able to kind of compare how you operate against others in order to do that. But that's probably one of the biggest drivers and one of the targets we're seeing, in the industry, in the oil and gas space for reduction. Trying to pick a number, obviously once you know where you're starting from, it's easy to start to show reductions from there. But how do you know how far you have to go? And that's always the $1 million question. Can we reduce by 50%? Is that enough? Do we want to get down to a certain value? There's a lot of voluntary commitments up here that I kind of list out that already have commitment targets that folks can use as a template or kind of as a guide to determine where their operations probably need to be. So if you're benchmarking, and this is a thing within this industry, of course, everyone's kind of trying to see what everyone else is doing. So trying to understand where do you compare to to other operators. In addition, as we were mentioning, at the top of the presentation, since methane intensity, carbon neutral cargoes, various others is going to become a market differentiator, meaning if the methane intensity of the gas that you produce or the oil that you produce is lower than another operator, that could ultimately result in a price differential for your product. And there's a lot of talk about responsibly sourced gas, so I'm not going to steal anyone's thunder who go into really what that is and the certification around that. But at the end of the day, responsibly sourced gas is going to equate to a general methane intensity and operations for the products that you're using in this case. So these are a lot of the commitments that are out there. One future is one that's very well known of driving the industry, for example, to less than a 1% methane intensity on a kind of enterprise scale. There's others that are kind of guided by the Paris Agreement. The Global Methane Alliance, which has a very aggressive target of 0.25% in this case. So we're looking at numbers that are very, very aggressive over time frame. So I bring this all around since I've talked very high level on this. You establish a baseline, you set a goal. The next piece of that is going to be going ahead and implementing your reduction methodologies. I'll talk very high level about a few things. I bring this up. This is the marginal abatement cost curve for the oil and gas operations that kind of just show a lot of the reduction strategies that can be implemented will ultimately pay for themselves. In this case, there's a lot of low-hanging fruit that we see. Obviously, there's a lot more to get to that, what we would call the net zero level, do require, an outlay of capital, but there's a lot that can happen that can drive these reductions and meet those medium reduction goals very, very quickly by implementing different things. First and foremost is going to be measurement and monitoring. And you can break that up between kind of the bottom up and the top down. So bottom up is in the field, OGI, measurement events, understanding what the source testing, ambient fence line monitoring, mobile platform measurements, implementing additional monitoring that might go, again, beyond the regulatory requirements is going to allow you to quickly identify, quantify accurately, and then mitigate very quickly what those emissions are going to be driving toward those reductions. With the technologies we have now kind of on that top down is being able to utilize things such as aerial or drone, fixed wing aircraft, satellite imaging. A lot of this is data gathering that's going to allow you to act on what you're seeing, but being able to have access to what the emissions are and taking care of leaks, for example, and various other things is going to help in driving the overall reductions from your operations. Abatement options, within the supply chain. One of the biggest contributors that we see specifically on the production side is going to be pneumatic controllers. So One, having better data on what the actual emissions are from your pneumatics, getting rid of high bleed to the best of your ability with safety, replacing those with instrument air systems potentially, changing over any fossil fuel combustion with electric options, compressor seals, inventing cannot be captured, implementing vapor recovery units, blowdown minimization and capture, instituting flares where there might just be some direct release. Ideally, that should not be happening, but we know that still maybe exists in some cases. Installing a plunger for liquids unloading. All of these are pieces that, again, are different mitigation items that can be done that will help drive towards those reductions. And then kind of on the broader level, looking at what are some of those bigger reduction strategies of looking at eventually offsets. We know that just due to the nature of our business, we can't get the numbers down to zero. So being able to offset our emissions with other types of carbon credits, supporting projects that will drive emissions that would have a kind of a negative positive impact on that carbon capture and storage. There's a lot of movement in space currently with implementing renewable energy power, or either supporting that, the power development, or being able to actually do some of that within your own operations. Looking at energy efficiency projects, we see a lot of success in reducing redundancy, increasing the overall efficiency, for example, of compressors and of what the operational needs are. And on the mobile side, fleet conversions. So looking at mobile sources that are much more energy efficient. So I kind of have presented a lot in that, but what I hoped to do again was to kind of set the stage on why a lot of these presentations across this conference are really, really important, specific to the targets and the goals within the oil and gas industry in particular.